Here's an example that you can try. I'll start it, then you can stop and try it on your own whenever you want. So here's a NASCAR example. You got a particle moving around a circle. There's the equation of the circle, and y dt is 7 feet per second. Now, since this is positive, the y coordinate is changing in a positive direction. So this information wouldn't work if the particle was over here, because it'd be headed down over here. So this would only work on this side of the circle if it's moving this way around. Let's find its rate of change in the x coordinate when it's at the point 3, 4. Right, so you take the equation that relates the two quantities. So you have the rate of change in y and the rate of change in x. This is the one you know, and this is the one you want to find. This is going to be key later on, looking at these two variables. So I need an equation that relates x with y, and it's the equation of the circle. So I'm going to take that guy's derivative. Now you should always think to yourself, are x and y changing over time? Is the position x, y? Yes, it's moving around the circle. Okay, so take the derivative with respect to time. Both x and y are functions of time. Okay, the position's particle, how about the particle's position, x, y, is changing. So these are functions. Even x is a function of time. So we're not taking the derivative with respect to x, we're taking it with respect to time. These are both functions. So 2x dx dt, 2x derivative of base, plus 2y dy dt. Now think about this as being in parentheses. Bring down the 2, reduce the power by 1, take the derivative of the base. The derivative of a number is always 0, no matter what the variable. Constants are not changing. Okay, so here is my related rate equation. There's my RR. Okay, now at this point, I need to know everything except for what I'm trying to find. So x and y are the position. I know dy dt, so I can figure out dx dt. I'm going to substitute and then solve. You could do it the other way around, but so 2, the x coordinate is 3. I'm trying to find dx dt. 2 and then 7 equals 0. Now if I wanted to, I could have divided this entire equation by 2. But so 6 dx dt plus 8 times 7 is 56 equals that. Okay, so now I want to solve for this value, this variable here. So I'll subtract 56 from both sides and then divide by 6. So first thing, subtract 56 from both sides and then divide by 6. And that's going to be the rate of change in the x coordinate with respect to time. Now it's negative. But if you go up here and look, the particle's moving that way. So it's, its direction is in the negative x. So that's great. And let's see. It's measured in feet per second. So this must be feet. And this must be feet if you were to label the axes with their units. Okay, so this is feet per second. If you must know, 56 divided by 6 1/3 negatives feet per second is the rate of change in the x-coordinate when the particle is exactly there. The particle's at a different spot. These two values will change, so this is going to change. Okay. Take the derivative first before you substitute.